All right, so again, volume test on Friday, go to tutoring. Here we go. So, we're going over surface area and volume of spheres. I know we already did surface area on the last unit, but we are doing surface area of only the spheres on this note sheet, okay? So, where would you find these formulas if you were not sure? Formula chart, right? So, surface area of a sphere. And I hope everyone knows a sphere is what it looks like, right? I mean, what do you think a sphere looks like? I mean, it's circular-ish, but it's really a 3D figure, kind of like a basketball. Okay, so that's the ball shape, globe shape, whatever. So, surface area formula for a sphere. I look on here, kind of near the bottom, kind of. 4 pi r squared. And then for the volume, now that's near the bottom of the page. It's the last one for sphere. Notice the difference here. This one is 4 over 3, 4/3 pi r cubed. I want you to notice that's cubed and that's squared. They're different exponents on these formulas, okay? So we got 4 pi r squared and 4/3 pi r cubed, okay? So when do you use which one? You got to look for the key words, surface area or volume, okay? That's how you can tell. So, spheres are a set of blank in space, okay? It's a set of points in space that are blank distance. They're equal in their distance from a given point called the what? So, from right here at the center, all the points that are equal distance away from that center point, they make this round thing called a sphere, okay? So we all know what a sphere is. And then the next one, if you're looking at the board in green here, what do we call half a sphere? A hemisphere, okay? That H-E-M-I, is kind of the half part of it, so a hemisphere. Y'all ever been downtown to that park? Hemisphere? Not to be confused with that, because it's spelled different, all right? Hemisphere. Do not fear the hemisphere, all right? Now, a blank blank is a circle on the sphere that divides the sphere into 2 blanks. So, check it out. Does everyone see this thing right here? It's dividing it. It's called a great circle, okay? So a great circle, they're great. So anyways, great circles are called great because they are exactly halfway, okay? They cut a sphere in half, okay? Now, you know you could slice it and it not be completely in half, but if it slices it in half, that would be a great circle. And it says there's a circle in the sphere that divides the sphere into 2. You could put halves, but we're going to put hemispheres. That's what the halves are called. Hemispheres. Okay, and that's kind of the end of the note, so we're going to apply this on the bottom on example 1. So make sure you got this down. Slowly moving it down. We actually do have one more thing to fill in, my bad. Since a sphere has no blank, okay? Now, imagine a sphere, okay? It has only one surface, right? Like there's not a top and a bottom and a side because it's all the same surface. So, since a sphere has no sides, meaning one surface, right? There is no such thing as what surface area? The side surface area, which is lateral, okay? So there is no lateral, but there is total. And when you look at your formula chart, the surface area is under total for a sphere. But there's nothing for lateral. Because there is no lateral, because there is no sides. And that's why. Okay, now that you got all that down, let's look at example 1. Okay, example 1 says find the, and let's underline that key word, total surface area. So I'm not going to use the volume formula. I'm going to use the surface area formula, right? So what is the surface area formula for a sphere? 4 pi r squared. Very good. So let's do that. Total surface area equals 4 pi r squared. Okay? Now, I'll look at my picture. What's the radius? So the radius is from the center to the edge. So it's not 50, it's half, which is 25, right? So we would like to write down what we have. So we know r equals 25. And that's the only thing missing in the formula. So all we got to do is replace r with 25, plug it in, get our answer, ta-da, right? It is that easy, okay? And we're right here. You got something to write with? All right. So let's fill this in. 4 pi and then 25 squared. Let's take it to the calculator. 4 pi 25 squared. I got it up here. For 4 pi 25 squared, I got 7,853.98. Now, what are my units? Centimeters. Okay, so everyone writes centimeters, cm. But since I'm doing area, how many dimensions? 2-dimensional, so it's squared. Okay, surface area is still squared. When we get to volume, then we're going to cube, third power. Does everyone have this down on the bottom of the first page? Because we're going to flip it over to the next. So if you're ready, flip it over to the next. Okay, I'm going to flip it. We good? All right. We'll come back to it if you need to. Now, this is the same exact picture, but let's read it. Find the total volume. I'm going to need to use a different formula. So let's go back to the formulas. What's the volume formula? 4/3 pi r cubed. Let's write that down. V equals 4/3 times pi r cubed. Once again, what's the radius? Half of 50, 25, okay? So, all we got to do is replace r with 25, right? You got a pencil? Let's do this. So, equals 4/3 times pi 25 cubed. Now, you may or may not know how to type that in the calculator, okay? So I'll show you. So 4/3 pi 25 cubed. So let's go to the calculator. So when I type this in, you can either do it 4 divided by 3, or you can do control divide when you do it. So you do, actually, hold up, 4 control divide 3. Okay, so if you like it to look like a fraction, when you hit divide, hit control right before that. Okay, so let's do it this way: 4/3 times pi, and then times, what do we got? Oh my gosh, 25 cubed. So here's how we type this. Is everyone looking? This might be brand new, so you need to know this. 25 cubed. You're going to press 25. Don't press squared, but press the button right next to squared. This little upside-down V-looking thing is called a caret. Yes, like the vegetable, a carrot, okay? You hit the caret, and do you see the little blank that opened up? You can put any number you want there, but we're going to pick 3, right, because it's cubed. That's how you do it. Caret is how you get an exponent, FYI. So we get 65,449.8. And my units are centimeters what? Volume is 3D, so we put a little 3 cubed on that centimeters, okay? So surface area squared, volume cubed. Those are the differences. Now, for now, we're not going to do this part off to the right, so we can scratch it out. But FYI, terms of pi, you would not multiply pi, and you could get a different format. We're not going to do that right now, though. Okay, we're going to get to circles later, and we might revisit that. Okay. Now, let's look at example 2, and then we're done with the notes part. Okay. Now, what is that shape again? Hemisphere, right? So this says to find the total surface area and the volume of a hemisphere. Now, if you have your formula chart, which you don't right now, which is fine, but if you had one and you were like hemisphere, and you start scouring the page and you keep looking and looking and looking, you would not find a hemisphere on your formula chart, okay? But we all are smart. How do you think you're going to find the volume or the surface area of a hemisphere? We're just going to take a sphere and divide it by 2, okay? That's it. You can either do it that way, or you can do 1/2 times whatever, right? Either way you do it, it cuts it in half, right? So here's the deal. You don't need the formula, but you do need to take the formula of a whole sphere and cut it in half, right? So let's do that. And that's what it kind of says right here. There's not a formula on the formula chart for a hemisphere, but we know that it's the lateral surface area should be half the total surface area, okay? So let's not do that though. Let's talk about surface area first. So we're going to do 1/2 times the total surface area. Okay, that's what we're looking for. So 1/2 total surface area. Now let's think about this. If I take the outside surface of a sphere and I cut that in half, that just gives me like the dome, okay, the outside. Does everyone see that there is a bottom of this now? What shape is that? A circle, okay? So basically we call that a base, right? That bottom surface. So if I'm finding the total surface area, okay, it's half of the sphere plus the bottom, which is a circle. Okay, so plus B. Call it capital B. Remember we've done this before, area of the base. Okay, so again, for total surface area of a hemisphere, it's half of the total surface area of a sphere plus a base, because we got a circle in the bottom, right? So what is the surface area formula for a whole sphere? 4 pi r squared, right? So here we go. 1/2 times 4 pi r squared. So that's my hemisphere on the top, right? Plus B. Now, if that's B, how do I find the area of a circle? So formula chart helps you in that situation if you forget, but it's pi r squared. Big B for a circle is pi r squared. So over here, for big B, I'm going to put pi r squared. So it looks kind of complicated, but it hopefully makes sense. Half of a sphere plus a circle. All I have to do is replace r with the radius. What is r? 7. So let's replace this stuff. 1/2 times 4 pi 7 squared plus pi 7 squared. So let's go ahead and plug that into our calculator and get our answer. So 1/2 control divide time, and notice I have to go to the right, times 4 pi 7 squared, 4 pi 7 squared, plus, and then we have pi 7 squared. I know it's kind of ugly, but you can do it. 1/2 4 pi 7 squared plus pi 7 squared gives me 461.81. And my units are feet what? Surface area means squared. Okay? So again, I know hemispheres are ugly, but it's alright. Okay? Alright. Now volume. Again, for volume, if it's a hemisphere, what do I do to the formula for volume? So a hemisphere is how much of a sphere? Half. So what do I do to the formula? I cut it in half, right? So what I'm going to do is half times the volume, right? For a hemisphere. So what is the volume formula? 1/2 times, and my formula is 4/3 pi r cubed. So 1/2 times 4/3 pi r cubed. Sorry to move it so much. What is the radius again? 7. So all we're going to do is plug in 7 for r. So it's 1/2 times 4/3 times pi 7 cubed. Okay? All we did was put half in front of the volume formula because it's half of a sphere. But when we get to the practice, I can show you if you get stuck. So let's plug this in. 1/2 times 4/3 pi 7 cubed. So 1, control divide, 2, go to the right, times 4/3, so 4, control divide. Oh my gosh, hold up. Oh my gosh, we'll just do times 4, control divide. Why? Why? All right. Here we go. Let's see if it works. Oh. All right. We're going to old school. 1 divided by 2 times 4 divided by 3 times pi. And we're doing 7 cubed. So does everyone remember? It's 7 caret 3. So 1/2 times 4/3 times pi 7 cubed. Okay, whatever. It's always going to look ugly. So, but that is the right answer. It's just not the way I would like to see it on my calculator, but it's whatever. Okay, so we get 718.38. And what are my units? Feet, and volume is cubed. Okay. Now, once again, okay, we are in the period where we're between Avengers movies, but you can still Hulk out and remove the paper from the other paper. The second page is your assignment. It's 4 problems. They have 2 parts, most of them. It's just what we've been doing. So if you're like, what? Look at your notes. Okay, there's an example on there just like what you're doing on there. Promise, okay? So again, surface area and volume. You can do it. I need you working on this assignment today, and if you finish anything, make sure you've turned in all your missing work, and especially this week, because it's not on your progress report yet, okay? The volume from last week, you got to do those, okay? Let's go ahead and get started.